There are people who has already.
Almost afternoon, not yet. Not yet. I think we're on time. So nice to see you and have you lots of different. It's really interesting, and I am doing the work for present.
They have already. No. Yes. Yes. Okay. So shall I start? Thank you for coming, and thank you all the people who is attending the talk online. Thank you the organizers, the scientific committee, and the local organizers to let me give me the opportunity to be here and present our work. Today I'm going to. Is it recording?
Recording
Automatically, yes. Okay. Today I would like to present the article accepted and appeared in the proceedings of the conference. And my aim is to give just a few outlines of what is there in the article. So you want to read more details, just go there to the article. And I'm going to try to transmit my impressions of about using virtual reality in the teaching linear algebra, but also other subjects like algebraic topology, which is I will talk if we have time. I could talk also a bit in the 5 last minutes. So the software we are using is Neo3 VR. Neo3 means new geometry, is acronym name for French geometry. And the logo, as you see, has the five platonic solids. Maybe I can take my and you can see also, you can see my back. And I recommend you to download an app in the Play Store in Google. It's called AR Platonic Solids. And then you will see the logo in 3D, in augmented reality. So you are welcome to download this app, AR Platonic Solids. So the software is a total immersive VR and the dynamic geometry system designed especially for teaching and learning 3D geometry. Although I have to say that it is being used in other ambience like psychology. We have some projects to improve to stimulate cognitive and spatial skills in people with disabilities. So the software is somehow very flexible and able to be used in other areas apart from mathematics. Is developed by a spin-off of the University of Almeria called Virtual Door. Here you have the main developer of the software is Diego Cangas, and since this year, another student math degree, Ruben, has learned to develop the software. Right now, it is available in the most popular video game store, Steam VR, for systems like HTC Vive or Valve Index, etc. And also in the MetaQuest App Lab and the Rift Oculus Store you can go to this website and there you will find all the information. And currently we are dealing with researchers on didactics of mathematics and teachers of primary, secondary, and university levels in 3 areas: Andalusia, Spanish area, and also some Erasmus. I profit to thanks to these financial institutions to support our project. how I have been using Geometry in my classroom since 5 years ago. First of all, we had, you see this Oculus Rift with a cable, and you need a computer. Okay, this is a, let's say, 4 years old, and so I use it for teaching like now. So I suppose that we are in a classroom. I can give you some explanations on the blackboard. And when I need to be in 3D, I use either GeoGebra or other software. But if some parts need to be tricky and needs to see the good projection, also good immersion of the problem, then I use VR. Okay. And in groups, I also asked my students to do some activities in groups and small groups. What about, there is an option I will show you later, which is using these small glasses. These small glasses allows you to see in online or in, what's to say the name, in real time, what I'm doing in Geometry. So you can connect to a Zoom now, or maybe if you like, with the same Zoom, and use these VR glasses, which are just basic, €2. And then you will see what I'm doing in 3D. So I have a pair of glasses, and yeah, you can try with your cell phone you like. And finally, this year we are using these headsets, which is called MetaQuest. Maybe you know already, by Oculus, and right now is owned by Facebook, as you know. And the possibilities are just enlarged. So it's now very cheap to buy this. Before you need to have a gaming computer, and this was expensive. But right now, for €450, you can have high quality virtual reality in the classroom. So let's start. I'm going to, if you follow the paper, there is a sequence of activities that I have been made during three academic courses. And my idea is now I give you briefly what I'm going to do in the next 20 minutes. So first of all, I'm going to manipulate planes in Geometry to see all possible relative positions of three planes. And this is thought for first year math students that come from secondary school without no spatial vision, no spatial reasoning, only analytic computations, and they only see, they follow a table doing like if the rank of the matrix A is equal to the rank of the matrix B with when you add the coefficients, then is compatible. The system is compatible and gives you, depending on some rules they give you, which is has solution, a point, a line, or a plane, or no solution. You know what I mean. So they just follow an algorithm given, or a list of possibilities given by the teacher, but they don't really understand what they are doing. And I have seen this in the first days of my lessons. I ask students to draw this, and I can see some students that know what they are doing, but many others, they don't know what they are doing. So I decided to introduce and use VR for to get students used to this spatial vision. The second example, I'm going to use some tools in Geometry to find, for instance, the minimal distance between two lines, very easy example. But you will recognize here, when I'm moving, then I can see the angles, the 90 degrees angles correctly when I'm inside the the game. And the third, I will show you maybe a video would be enough, how to make a plane in the 3D system with these levels giving us the coordinates. I'm going to use the parallel tools and so on, some projections to find the coordinates with respect to a base of a plane. And the third video, I will show you how to use the graphing calculator to represent 3 planes or whatever you like. It can be used in differential geometry or other calculus classroom. And I have to say that many of the development of the software have been done by students in the final degree. You say there's a final degree work, I don't know, in master degrees, so I have involved several students to work with me and develop some part of the code and do some tests in the classrooms and so on. And the graphing calculator was developed by one of my students, Carmen. Some more fine exercises like finding, I can give you this, and then you can have a look at the kind of problems that we can do. This, all of this is in the article to find, for instance, here the intersection of a plane and a line. And also I'm going to see, to teach students, I have teach students to represent coordinates in 4 dimensions via the hypercube. And I will show you how to make it and how to do some coordinates there. And you can continue if you remember the movie by Flatland, or here we can use some scanner to represent the projections on 3D objects on the plane. And then this helps students to go to the 4th dimension. And by the way, you see the double screen. This is an stereoscopic screen, and you can see it with these glasses. So if you have, you want to use it, maybe later or now, just take it. And finally, I'm going to explain just the interpretation, geometrical interpretation of a linear matrix by giving the two frames in the space and showing the corresponding matrix. So students in this activity have to invent a matrix and find the correct references, the correct frames. The one could be the canonical one, and the other, they change the vectors and they see the changes in the matrix, so that they find algebra and geometric correspondence between the two. Okay, and finally, maybe I can show you, I can start now in the game, and hope it works. I need to fix the floor first and some area. And hopefully now you will see on the screen. Can you see this? Is it softly enough? I should be logged in. It is going very slowly, but I think it's because of the Zoom, you know? Maybe let me see. It's going very, very slow, sorry. And I don't know if I'm logged in. It's strange because it should be. I was before logged in, but not anymore. Okay. At least I can give you. Let me find this plane. So the first activity is to show relative positions of planes. So I can have this plane. I can make copy of it, Should be here. And make 3 copies. I can paint it. Let me paint. So tools can be taken with hands, as you see. And I can have to separate these 2 planes. And for instance, blue. Okay, you see? Can you see the planes correctly? Or so now we have 3 parallel planes. And then in the video, it is in the article, you can see that this will be, the matrix A will be of rank 1, and the matrix B will be of rank 2. But they have this, so we can see here the parallel planes. Another, I can rotate this, and then we can have this situation, for instance, and maybe that one. And then in the video, it's explained the corresponding matrix and why we have here rank 2. And it is important right now to explain to the students that the coefficients of the planes are the normal, the perpendicular vectors of the plane. So I can play with these perpendicular vectors and show them the correspondence between the coefficients of the matrix, so the lines, the rows of the matrix, the horizontal rows, and the coefficients of the plane, and the correspondence between the ranks and the the linear dependence of the normal vectors. So you have this normal here vector, and you have here another perpendicular vector. And what you can see is that these 3 vectors are linear dependent, and so the rank will be 2, which is the rank of the matrix A. So you see, that's the idea of working here and explaining students the correspondence between the algebra and the geometrical part. And with this, you can continue with other the 7 positions. So for instance, here gives you rank 3 and the matrix B rank 3. You get the point, and you have also when this other position, the solution is a line. And what else? I'm missing maybe that one. The 2 planes coincide and the other not. And I'm missing this one, 2 parallel, 2 equal and 1 parallel, and the 3 equal. So you can get all, maybe I have missing some of the positions, but this is why I have been using this Now let me go to the second video. Should be here. That's the plane. in the video, I have added some you see, some explanations of the Rouchet-Frobenius theorem. And at the end of the video, you will see in 3D the correspondence between the plane and the coefficients of the equation and the vector. So here students can see that parallel planes have the same normal vector, and in these three axes I can move the points and have different equations, and you can ask students to do some exercises of this kind. So this is a very easy example for us, but for students, it takes they like it, okay, and they I think they understand what we are doing in this way. And let me go to the website of Neotri where I have more videos. Let's go. You go here to the community. And go there. And elementary geometry. The second activity is about well, could be this one. By the way, this is my, I can show you this, hope it works. So this is a graphic calculator. So we can insert images in the scene, and you can have the questions and ask the students to represent the planes in the graphic calculator, okay? So for this, they have to parameterize the planes, because the graphic calculator requires parameterization. So students in this way, they have to go from Cartesian equation to parametric equation. They introduce the equation and then they can give in. Let me go faster. In this way, they can. Yeah, you can change the intervals of the parameter u and v. You can make more subdivisions or less to have little squares in the planes to have more. You can save every what you do in Neotri, it can be saved, and then you can download, open whenever in your activities. Here are the three planes. And here you can see the intersection point, okay? But there is another option, the graphing calculator, but these are STL files, so you cannot really, these are given by like an external mode, but you can, here I'm showing how to use if we want to show only the grid or the mesh, you can change the colors of everything. And there is an option of internal mode that transforms these planes into vertices and edges. So you can use the tools of on the table. In particular, the intersection tool. So in the intersection tool gives you a line with vertices and the edge, and it computes also the everything you like. And what else? And here And here it's an example of how to draw an equation. For this, students have to find 3 solutions, and then so use the 3 axes to draw the points. And the thing here, you cannot give a distance and then it draws the point. No, you have distance are real. So in the world, a meter is a meter, and decimeter is a decimeter. So you can use a grid. We have a grid separating by 1 decimeter in every x-axis. And to do fractions, then you have to subdivide the segment, and there is a tool to make subdivisions. Okay, so it's quite intuitive. And this is as you see, it's stereoscopic, so you can see the video here in 3D. And as you see, one of the solutions is 2/3, I think. It uses 2/3, so you have to divide the segment in 3 and ask the student to do this point. So let me go into the end. And here I ask students to use the perpendicular tool to touch 1 point and or 3 points. The middle point of the 3 points of the barycenter, and then build a perpendicular with a perpendicular tool. So there is a perpendicular tool that you touch 3 points, and it gives you the cross product of the vector.
So
yes.
So I understand correctly. You have to be an expert to create such a thing, or is it how much time do you need?
Depending on your age.
Mm-hmm.
If you are a children, in 5 minutes. If you are 10 years old, 5 minutes. If you are 50 years old, you need 1 hour. So by experience. Let me make you how to use the basic tools here. So I'm doing a plane. Okay, you see, here are the basic actions, and I have touched this one. So if I want to do some perpendicular to this plane, I need to first, as I said, we can make this middle point tool. They have, you see a blue end, and you press the trigger button, and then you touch the 3 vertices, and it gives you the middle point, the barycenter. And now for the perpendicular, either the same tool works, gives you many options. One of them, the basic one, is that if you touch 3 points, it gives you the perpendicular line following the right hand formula, as see. So you touch this, and this, then you get the other. Okay. And there are other options for the perpendicular tool we can see now. So if you touch 1 and then the plane, gives you this direction. So you can now, here you have, you're playing with your perpendicular direction. Okay. So it's very intuitive for students in primary and secondary school. And they can combine virtual reality with other softwares like GeoGebra, so it's not incompatible. So you can do exercises, written hand exercises, GeoGebra, and here do faster, in a faster way, the constructions. But in this way, the students get, in my opinion, well, we have proved this, they get better spatial vision, of course, because we are in 3D. Right. Here we can measure angles. We can measure distances, making parallels. For instance, if you want to make a a plane plane parallel to this one. So what you have to do is to make this vector and then make this parallel point here. You do this, and then you can get this parallel. And they should, so if you move this point, you can get the parallel. There is this option that allows you to change positions of vertices. This also moves parallelly the edge, and this moves parallelly the. Okay, here you have an example of the list of, I think you have seen the list of exercises. So all the exercises are doing in this way with very intuitive, with these intuitive tools. So let me continue with the videos. And in this other video, I show the concept of base and what does it mean, the linear dependence of vectors. So these are the basics, previous lessons to teach basis of vector spaces, because students in the first course of maths, they don't have this geometrical intuition, as I said before. So here in this video, I explain what does it mean generate a plane, and what does it mean linear combinations of two vectors, and still see this in a geometrical, in 3D. And what else? What is in this video? I show you. And here you have a vector generate. I'm finding the coordinates of a vector on a plane. So now you give a point in the plane, and then how to find the coordinates. So for that you have to use parallels, and like this, students better assimilate the concept of coordinates by using this geometrical point of view. So not only algebraic, okay? So here you have to make a parallel of one of the vectors and cross to the other vector line and find the two, this composition as a sum of two vectors, and then dividing the length of the projections by the length of the vector, generating vector, then they get the coordinates of the vector. Okay, so this was one of the, let's go to the next video. So I prefer to show the video because it will be faster, and if you are interested, we can play it later with the headset. So how I use Neotri to show the fourth dimension. So I explain as a typical that to get from 1 to 2 dimensions, you have to move a point. To get a line to get from 2 to 3, you have to 1 to 2, you have to move a line perpendicularly. To get the third dimension, you have to get a cube from a square. And now to get the fourth dimension, you have the cube, and you have to move in a extra direction called T or W. And now with this option, this T direction, and let's see, if I can show you coordinates here. So in this activity, I give students a question of a plane with 4 variables, and I ask them to draw points, to draw lines, and to draw planes. And we can also see intersections of well, planes and also 3D subspace, right? Because we are in 4 dimensions. And I ask students to draw intersections of subspace, because in algebra you lose this notion when you are in 4 dimensions. It's unbelievable that 2 planes could be parallel, 2 planes, or doesn't couldn't be parallel or doesn't intersect in 4 dimensions, right? So it could be that the intersection of 2 subspaces is 0. Two planes, in the sum of 2 2-dimensional subspace could be R4, but not in R3. And here students can look for coordinates, and as you see, they can draw a subspace, 2-dimensional subspace, and so on. There is some activities in Puzzle that I make a video and then I stop and I ask a question, and students have to solve the problem, have to say the solution. And like this, I evaluate this. Let's see if there are some more trying the questions, coordinates. And what I like of Geometry is that the vertices can move, and then you can pass from one standard, this version of the hypercube, to this other one, which is the standard one. So there you can show students what does it mean, what are the 2 cells, the 3 cells of the hypercube, and the 4th, the 1-4 cell. How a line generates a plane, how a face generates a cube, etc. And I can show them the stereographic projection in 4 dimensions. There is also another video. Here is more. Here is more on the hypercube. It's not there. So in the paper, there is a video, the link, where I can play like in flat land. So I invite you to see that video. I can show you the 4-dimensional sphere as a sphere going this, growing and getting smaller. Let me show this other video. So the idea of this activity, as I said before, is that you have 2 frames. So this will be the 2 bases of the, if you are in vector spaces, they are the basis of the first space and the images of the bases. So you give the map by the image of a base, of the vectors of a base. So in here, in Geometry, you can apply the transformation map. So you can see here a cube and the image. And you are moving the images of the base. So like this, you can see how the figure deforms, okay? Well, in general, these are affinities, so it's not a linear map. There is a translation vector going there, which is the difference between the origins of the 2 frames. So normally, so here you can do a lot of things. So first, you ask students to give a matrix, any matrix, and of kernel 1, of dimension 1, or of dimension 2, sorry, and represent this in Neotic so they can see the effect. And there you can see in the first column of the matrix, the first column, the matrix is the image of the first vector, the canonical vector, and the second is the image of the second vector, and the third. So here you can explain what are homotopsies, what are reflections with respect to planes. You can also recognize rotations, and in general, you can have affinities. But for the moment, the first year, in the first course, the introductory course of linear algebra, I think it's good to get the students get clear what a matrix means and what these geometrically represents. And then in the second year, they can go to, in the next semester, they can go to the endomorphism theory and by eigen values and eigenvectors, and then quadrics. But in this first semester, I find this very interesting for the students. Just a minute. So let me go back to the presentation. So the results are better detailed in the paper. We got good marks in the exercises, and but I didn't have a control group because I wanted that all students do the virtual reality activities. So it's a pity that you don't have a control group to really prove that these activities help students to be better. But maybe in the next course I can have a bigger group and can make comparisons and so on. So what I asked is about the use of this small gadget, and also the use of my way of teaching in the classroom. And for instance, when I presented the plane, how to draw the plane, I asked them if they could see geometrically the plane and the coordinate and the subdivisions and so on. And they say they understood very well how to represent a plane, because they don't do this in secondary school. They don't draw planes right now. I don't know why, but they only do analytical computations. It's a pity. They don't use pen and pencil. Yes, neither GeoGebra. So many of them, they didn't know GeoGebra. So they in the lesson they draw this kind of planes and system equations for the first time. So the second question, I asked them if this system of using VR and also these small glasses to see 3D videos, if they could help to visualize 3D geometrical concepts, and they say yes, and almost yes, because as you see, most of the group. And finally, I asked them if they would like to have more videos with this system, and they all say 90%. They say yes. So this motivate me. They push me to make more videos and go ahead with this way of teaching. So for me, it was very pleasant that students like this way of teaching. So some conclusions to finish. It is natural to study 3D geometry, not in the flat screen, but in 3D. So this is clear. I think you will not have any doubt about this. If you are doing 3D problems, it's better to work with them in the 3D space. Neo 3VR provides a suitable environment for this, to do this. As one of the subjects that I have talked about today, linear transformations, for instance, are easily handled and visualized in VR. So students can see with this real VR. This is not VR. This is like something different. So they understand the connections between the algebraic and the geometric part. And by the new multiplier mode, so they can permit either the teacher with the students or between the students to work together in some geometrical problem or construction. So I think this will be the future of this teaching and learning geometry. And if I have some 1 minute or minute, there are many tools that I haven't shown you. So if you are interested, and now we can have time and I can show you. For instance, you can import STL objects, modify them in VR so you can see exactly how is the figure in real time, and then you can export it. Also, which is work in progress, is that you could import files from GeoGebra right now. If other softwares are interested, we could also try. And here is our community. You can have a look. As I said, there are plenty of activities and plenty of things that I haven't talked about today. So you are welcome to visit our website and follow us in the social networks. And that's it. Thank you very much.